Okay, good morning. So today we're going to talk about number systems and specifically our number system, the base 10 number system, but we're going to gradually go into different number systems like octal and binary and hexadecimal after a while because those are the number systems computers work best with. But to get to there, we want to understand the whole idea of what what our different number systems are, starting with our own base 10 number system. And to give an example of kind of like the mindset we should have going in, I have this picture of 3 apples. Now, if you were to write out the number of apples in this picture, you would probably write 3, something like that, right? That's the number of apples in the picture. The main idea of what we're doing is that this 3 is just a symbol. It's an arbitrary symbol that we use in our everyday lives. And arbitrary meaning it doesn't matter in the long run. We can use many different symbols. And in other number systems, we might write out this number of apples instead as 1 1. We have 1 1 apples in another number system. And in our number system, which is base 10, which you usually write with a little subscript if you want to write out what base number system you're using, you would put a little subscript of 10 down there, is equal to 1 1 in base 2, which is binary. So 1 1 in binary is the same thing as 3 in our number system. And that's what I mean by we can just use different symbols to represent the same idea. The idea that we have 3 apples in this picture. So a lot of this is going to be weird at first, but hopefully it will make some sense. So to begin with, our number system is called the decimal number system. Decimal number system. All right. And this is base 10. We would say the decimal number system is base 10 because all our numbers are based on powers of 10. Deci comes from in decimal. Deci comes from the Latin word for 10, and this is the number system everyone uses. 99% of people will use for most of their lives, but computers do not really like the decimal number system. That's why we're going to learn about these different types of number systems. So how does our number system really work? Why is it base 10? Like, what does that even mean? Well, let's take a number like 4,825, right? Normal looking number, whatever. But when we say out this number, the 4,825, what we're really saying is that we have 4 thousands, we have 800s, we have 2 tens, and 5 ones. And each of these sort of categories is like based on a power of 10. So 4 thousands, literally we can just write out as 4 times 1,000. We have 4 thousands. 800s, we could write this out as 8 times 100. We have 8 hundreds. We have 2 tens, so 2 times 10, and 5 ones. 5 ones. So we can break this down even further. We're in the base 10 number system, so everything's based on a power of 10. For example, we can rewrite 1 in this 5 times 1 as 10 to the 0th power. Because anything raised to the 0th power is 1, but that it still counts as a power of 10, 10 raised to the 0th power. And then for 10, the 2 times 10, we can write that out as 2 times 10 to the 1st power. Because anything to the 1st power is just like the number itself. So 10 to the 1st power is just 10. And then 8 times 100, we can write that up as 8 times 10 to the 2nd power. And then finally, 4 times 1,000 can be written as 4 times 10 to the 3rd power. And that's what I mean. This number, 4,825, is really just a collection of different powers of 10 sort of added together. So let me see if I can write this out. Go down a little bit. So this number, 4,825, is equal to 4 times 10 to the 3rd plus 8 times 10 to the 2nd power plus 2 times 10 to the 1st power plus 5 times 10 to the 0th power. And that's what I mean when I say this is a base 10 number. Every digit in this number is with respect to some power of 10. And we can do that for any number in our number system. Hopefully that sort of makes sense. This number system was kind of like formulated by it's called the Hindu Arabic number system, because that's where it sort of originates from, and we're pretty familiar with this. But it turns out computers do not really like using this number system. They like using stuff based on powers of 2. Because computers run on different on and off switches, which have 2 states, on and off. So we need to kind of develop our way towards a base 2 number system. But one question you might ask is why did we gravitate towards a base 10 number system? Well, it's because we have like 10 fingers, basically. We have 10 fingers. It's the easiest way to count numbers. So it's natural that like we as humans would sort of go towards a base 10 number system. Okay, so another number system that's sort of like a step down from ours would be what's called the octal number system. So we have the octal number system. Octal number system. System, which is base 8, because that prefix octo or octal, like an octopus, means 8. So how can we imagine this octal number system? How can we make this make sense, sort of like the way we know base 10 makes sense? Well, it's basically like, imagine you had 4 fingers per hand, so a total of 8 fingers on both hands, and you were trying to count the way you would normally count with our fingers, so we'd raise one finger and we have 1, And then our second finger would be 2, 3. Our fourth finger would go up, and then we would switch to the other hand. We would raise our fifth finger, sixth, seventh. But then what happens is, at least when we're counting with fingers, when we get to that last finger, that would be our 10. And it works the same way in the octal number system. After we hit the last finger, assuming we have 4 fingers on each hand, right, we count 1, 2, 3, 4, 5, 6, 7, and then we go to 10. And that is sort of the basic premise of how this octal number system works. As soon as we get to that last finger, we then jump another digit up like we would do with base 10. So there is no 8 as we know it in the octal number system. It kind of stops at 7. And this is a little weird, but let me see if I can demonstrate. Hold on 1 second. So think of it like this. Here's a picture of what's going on, right? You're counting, 1, 2, 3, 4, 5, 6, 7, 10, because you only have 4 fingers. It's a little weird, but that's how it works. And computers kind of like this because 8 is a nice power, or I shouldn't say multiple, it's a power of 2 to the third power. So computers tend to like this system. And then just if we were to keep going, right, you would basically just skip everything that contains an 8 or a 9 in it. So 0, 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17, 20, so on and so on. And even when you get to that last, notice over on the end, we have 70, 71, 72, 73, 74, 75, 76, 77. We don't go to 80 because, again, 8 doesn't exist in octal. We would jump right to 100. We would skip anything with an 8 or a 9 in it because we stop as 10, or I mean, not 10, 7 is at the largest singular digit in the system. It's a little weird, but once you get the hang of it, it's really not so bad. So let's move on to a different example. Let's see. Okay, so just like how in our number system things are sort of based on powers of 10, in the octal number system it's based on powers of 8. So let's take a number like 3,725 in base 8. I really shouldn't have said 1,000, but whatever. In base 8, it's broken down into powers of 8. So just like that previous example we did where we broke it down into powers of 10, now it's sort of we break it into powers of 8. And we write this little 8 on the subscript because that means we're working in base 8. So we can sort of look at it like this. We would have 5 times 8 to the 0th power plus 2 times 8 to the 1st power plus 7 times 8 to the 2nd plus 3 times 8 to the 3rd. Now I'm writing out the 8s, even though I said 8 doesn't really exist in the octal number system. I'm writing out like this because this is a way we can convert the number into our number system. So really, this, all that's going on here is now in base. This is kind of like how we would write it out in base 10. Oh, in order to convert the number. So to convert the number to our number system, we would just write the math out. So this would equal, so 8 to the 0 is just 1, plus 2 times 8 to the first power is just 2 times 8, plus 7 times 8 squared is 64, plus 3 times 8 to the third is 512. And we would just keep doing the math to this. So, 5 times 1 is 5. 2 times 8 is 16. 7 times 64 is... I'm too lazy right now, so I'm just going to grab a calculator real quick. 7 times 64, that is 448, plus where is it? 3 times 512 is 1,536. And then to get our base 10 answer, we would just add up all this together. So add this with the 448 plus 16 plus 5. And we get 2005. So this is the base 10 equivalent of 3,725 in our octal number system. These two numbers are the same. So 2005 in our number system is 3,725 in the octal number system. So one last thing to note is that within the octal number system, we would kind of treat these numbers like they're based on powers of 10. So let me explain. Let's take that same number, 3,725 in base 8. If we're thinking of everything in terms of base 8, we would write it like this. 3 times 10 to the third power, but 10 is in base 8. Not base 10 like our number system, in octal's number system, base 10. Plus 7 times 10 to the second power in base 8. Plus 2 times 10 to the first power in base 8, plus 5 times 10 to the 0th power base 8. This is a little weird, but within the octal number system, it's still kind of based on powers of 10. And the reason for that is, if we sort of think about what's going on, 1 in base 8 is equal to 1 in our number system, base 10. And 2 in base 8 is equal to 2 in base 10 as well. And we would keep going like that all the way until we get to 6 in base 8 is still equal to 6 in base 10. And 7 in base 8 is equal to 7 in base 10. But then, once we go past 7, we jump to 10 in base 8. And 10 is in base 8 is equal to 8 in base 10. That's why it's still, like, if we look over here, right, it's still kind of based on powers of 10, just within the octal system, but not in our number system. On our number system, it's based on base 8, because not base 8, it's based on 8, because 8 in base 10 is equivalent to 10 in base 8. And you could keep going like this, so 11 in base 8 is equal to 9 in base 10. 12 in base 8 is equal to 10 in base 10. So these things are a little off. That's why when we want to convert octal into our decimal base 10 number system, these 8s are actually on base 10. So I should write the subscript base 10 here. Because the way we would think about it in our number system, it's based on powers of 8. But within the octal number system, it's based on powers of 10. So kind of confusing, but we'll get a little bit more into it later. Clarify some things up, because I kind of did this off the cuff. I don't know if it's the best explanation, but I will make another video where I kind of go over this stuff again and explore how I can get to other types of number systems as well. So thank you for watching.